All right, so today you're going to be driving from St. Louis to Chattanooga, Tennessee. And there's some interesting things you're going to be driving through. You're actually going to get into the Appalachian Mountains, and I'll tell you about that in a little bit. In the meantime, you're going to be driving across a lot more sedimentary deposits, limestones and shales and sandstones. So you can imagine a sandy beach that would eventually become sandstone, and if you get into deeper water it kind of comes like a real muddy kind of stuff, and that's what silt would become. And then limestone is an interesting rock because it's entirely composed of shelled organisms. So anytime you see limestone, that was marine life at one point that had calcium carbonate shells. Pretty interesting. Lots and lots of former lives represented by limestone. And when you have a sequence of limestone and shale and sandstone, that shows that the shoreline either transgressed onto the land or it regressed away from the land, and the order of the sequence would tell you what type. So you're going to see a lot of limestones and shales and sandstones. You're also going to see a lot of cherts, which is kind of like agates or jaspers. It's a cryptocrystalline. It's very, very sturdy. It has a hardness of quartz, which is 7. It's very sturdy, and you get a high occurrence of chert in Louisiana, which is interesting. In fact, a lot of the roads there use chert as the aggregate for the roadbeds, which is kind of interesting. The Appalachian Mountains, they're really fascinating. 480 million years ago, kind of when Pangea got all put together, it's like the major supercontinent from our Earth's history, and it all collided and it built up a mountain range in that general area, comparable to the Alps or the Himalayas. They were enormous, freshly built, crushed up mountains. 200 million years passed and things eroded. 270 million years ago, when North America and Africa collided and got smushed together, and that built up another series of mountains right in that same spot. And that mountain building, it was an active plate margin, kind of like what we have here on the West Coast, and for 50 million years it was an active plate margin, and things accreted onto our continent from the east side. It wasn't east geographically at that time, things kind of drifted around since then. But it got accreted onto that side. And then at 220 million years, the plate margin there became passive again, and so these huge, tall pile of mountains, which is at least the second set that we know of. There's some theories that there was at least 6 mountain building and eroding down episodes in that region, so there's a lot of Earth history there, which is really interesting. The active plate margin stopped at 220 million years ago, and then those mountains began to erode down, and eventually they eroded completely flat. But the Appalachians, as you know, are not flat. There's a lot of topography there. So what happened? So apparently in the Cenozoic, which started about 66 million years ago, right when the dinosaurs went extinct, sometime in the Cenozoic, there was an uplift in the region. And they think that the uplift was Earth's crust and the mantle below it is reaching some kind of equilibrium. So it's actually kind of bubbling up in a manner of speaking. So that's why it's a high uplift area. Appalachian Mountains kind of in a nutshell. You're going to be encountering it right before you encounter Tennessee, so you're going to see a lot of flat sedimentary rocks like you've been seeing the last several days, and then you're going to start getting into some more like mountains, more exposed rocks, and that's kind of the start of those Appalachians, and it's beautiful. They're really interesting. You're seeing what are those called? So you're seeing the Appalachian Basin sediments in that area, so it is a lot of sedimentary rocks. If you go north, kind of like in the Blue Ridge and higher up, you get to the crystalline segment of the Appalachian rocks, and that's like the inner stuff of like the igneous and metamorphic rocks. So but y'all are in the basin, so it's more sediments. All right, hope you enjoy your drive today, and I'll see you later.